All right? Now, this should bother you already, the fact that there are two sequences in here, or series, sorry. So let's look at the conclusions, because there's three different things that could happen here. First of all, it says, if B sub n converges and A sub n is less than B or equal to B sub n, then A sub n converges. All right, so let me explain to you how this is going to work. This test is awesome, all right? A sub n is given to you, okay? So that's like the one we just did. I'll throw it up here just so you can see what I mean. Like the series we just did was n squared over n cubed plus 1, right? That was the one we just did? That's given to you. You're asked, does that converge or diverge? To use the comparison test, what you have to do now is compare it to another series. This one. You choose. You get to choose what series you want to compare that one to. All right? It's up to you. But here's the thing. You need to know what this does. You need to know what the series you're comparing this to does. And then if the series that you choose converges and this inequality is true, then the A sub n, the blue one up over there, must converge. Now I'll show you in a picture, an illustration of why this is true. All right. Let's say that you've got your blue series here. Sequence of numbers, right? Here they are. They're always positive. All right, there it is. That's your blue one. That's given to you. You come in here and you compare it to this other series, this one, and notice that what we're saying has to be true. The A sub n's have to be less than the B sub n's. So the red dots, where are they going to go? Above all these dots. Right? Wouldn't this mean that my B sub n's are always bigger than my A sub n's? Now, if the sum of the B sub n's, the red ones, converges, then the blue ones are smaller, aren't they? So that must converge also. Does that make sense in the pictures? That's the first thing that could happen here. The second thing, so look at the number 2 on there, or part 2. Part 2 says, if the series that you choose diverges, right? If it diverges and this inequality is flipped, then this guy must diverge. So let's see if we can make sense out of that. I'll take away the red ones. Here's the one you're given, right? You compare that one to a red one where all your red ones are smaller than the blue ones instead of bigger. And we know that if we add up the red ones, it diverges. If the blue ones are bigger than the red ones, then the blue ones summed up together have to diverge. Does this make sense logically to you? Okay. And then part 3, which is a little harder to explain with pictures. You'll just have to kind of take this one a little more on faith. The third one says, if the limit as n goes to infinity of A sub n over B sub n is some constant, and this right here is a positive real number, so what you're doing is you're taking this sequence in here, in the given series, and you're comparing it to the sequence in the one you've chosen, if the ratio, the limit of that ratio is a constant, then whatever happens, they do it together. So if one of them converges, they both converge. If one of them diverges, they both diverge. Huh? We have to see this in action, don't you think? Okay. So let's do that problem again. I'm going to do this problem right now, but now I'd like for us to try a different technique. So we're going to do sum n equals 1 to infinity, n squared over n cubed plus 1. We could use the integral test, right? We did that already. But I'd like to try and compare it to something. So I'd like for you to think about this. If n is a huge number, does this plus 1 really make that much of a difference in the bottom? Like imagine that n is like a billion, gazillion, gajillion, whatever number, right? Then adding a 1 to it really doesn't have that much of an impact on it. So would you agree that this really kind of behaves, it's kind of approximately, not exactly, but approximately this series, which is really just what? 1 over n. See, I'm trying to come up right now with something that I want to compare it to. And I know that this is pretty much this, isn't it? So this is a natural candidate for what I want to compare it to. Make sense? So if we go back to colors, because we love colors, this is my blue series. That's what was given to me. And this is what I'm going to try and compare it to. Now let's discuss real quick about this series. What do we know about it? It's harmonic. And it diverges. Right? So go to your little table now for comparison test. And there was part 1, 2, and 3. Which part are we going to have to make happen? Part 2 or 3, right? So let's look at part 2. With the part 2, it said if the series that you're comparing it to, right, diverges, which it does, and what inequality had to hold? So it said if this thing diverged, which it does, and what was it? A sub n was greater than or equal to b sub n, and a sub n is greater than or equal to b sub n, then we would have the conclusion that we need, right? That one would also diverge. Now, what is a sub n? We didn't write it down, but what is a sub n? A sub n is just the sequence, right? N squared over n cubed plus 1. What is b sub n? 1 over n? So do y'all understand that what I need to do now is ask myself whether or not that's true? If a sub n is greater than b sub n, we're in business. So let's write it down and let's see if it's true. Is n squared over n cubed plus 1 greater than or equal to 1 over n? Question mark. Is that true? If it is, we're done. What you cannot do right now is just start plugging in numbers and checking. You actually have to algebraically determine this. So how about we do like clearing of fractions, kind of like the cross multiply thing? If we do that, what would we get? So like multiply n up there, you get n cubed bigger than or equal to what? N cubed plus, subtract n cubed on both sides. Subtract n cubed, what do we get? That didn't work. So one of two things, well, not one of two things. What we probably did was our comparison series just wasn't good. I mean, it seemed like the natural choice, but what we got at the end the comparison test didn't hold up. Do you see that? This inequality that we needed to hold doesn't hold. So we actually should take a step back for a second. And we should try and look at this and see, where did it fall apart? Where in this did it fall apart? This piece right here, right? That plus 1. It would be nice if I would have had something bigger over here, right? Like maybe n cubed plus 2 or something bigger. So is there anything I could tweak, just a slight tweak, to my choice that would solve the issue we're having? 1 over 2n? Is that still harmonic? I like that. How about that? Let's try it. What if we do 1 over 2n? Is that still harmonic? Yes. Okay, this changes our formula to this, right? And then we come over here and it changes this to this. And then when we cross multiply, what do we get here? 2n cubed. And now subtract n cubed from both sides, and what do you get? N cubed is greater than or equal to 1. Is that true? Yes. So that works. So what's our conclusion? It diverged. This diverges. So right now, I say, so therefore, by comparison test, sum n equals 1 to infinity of n squared over n cubed plus 1 diverges. Did I say converges? Did I? Okay, it diverges because that's what this one does, right? Interesting, huh? Sort of test. I know you're all burnt out, ready to get started on that take-home test, I know, but I still have 6 minutes. Okay. So I used part 2 for that because I compared it to something that diverged, right? If I try and do a comparison test right now with something that converges, I'll never get it to happen. Okay, so you have to kind of know what you're going for here. What about part 3? Let me see if I can use part 3 for that comparison test for this and draw the same conclusion. I still need to choose something to compare it to. Right? I still need a comparison series. So why don't I compare it to not the 1 over 2n, but let's go back to the 1 over n. I wonder if the part 3 for this will work. So what am I supposed to do for the part 3? Limit n goes to infinity, and I take the a sub n, which is n squared over n cubed plus 1, and then I divide that by b sub n, which is 1 over n, right? And I take this limit, and what am I hoping to get here? A positive constant. A positive constant. Well, let's do some algebra. Flip that up. Doesn't this turn into limit n goes to infinity of n cubed over n cubed plus 1? Infinity over infinity? L'Hopital? What happens after one application of L'Hopital there? Derivative of top? 3n squared. Derivative bottom? 3n squared. That's just 1, right? So this limit is 1. Is that a positive constant? What does that mean? Whatever they do, they both do. But I already know what this one does. This one diverges. This tells me they both have to do the same thing, so that means that diverges. Wasn't that clean? That was really, really clean. So therefore, that series up there converges. So these are all in your toolbox now, okay? This sheet of paper, these are your tools now, okay? You get to use them. Which one you pick, it's up to you. I have one more that at least we can look at. This one looks pretty complicated. Yeah, I'll get the sign-in sheet going around. We still have 20 minutes. I have to make up for that time that I had to step out of class, sorry. That's not right. All right, what are you thinking here? I'll tell you what you're thinking. Nth term test. Let just n go to infinity, and it's going to fail, right? Because that thing goes to 0. So that term's not going to work. Is it geometric? Harmonic? No. P series? Not really. That plus 1 really kind of messes things up, doesn't it? So comparison. What would you like to compare this to? Or do you even want to do comparison? Can you think of anything that looks like? If n was really big, come on, I know someone out there has some idea of what we can compare that to. We'll give you a hint. N? Where are you getting n from? Thrown out there? Okay. Does this one really make that big of a difference? Not. So square root of n cubed? Look, this may not work, okay, everyone? This may not work, but I'm thinking, if anything, it looks a lot like that, doesn't it? Now, what is this? N to the 3 halves, right? What is that? P series. This is a P series. Do you know what this P series does? It does what? P is 3 halves. It's bigger than 1. This converges, doesn't it? Okay, so if the series I want to compare it to converges, then what I need to see is whether or not A sub n, so this is the question, is A sub n what? How's the inequality? Less than. Think about it this way. This one actually goes to something, right? We want that one to go to something also, which means we need that one to stay smaller than this one. So it's got to be, this inequality has to hold, right? Which means you have to see if 1 over square root of n cubed plus 1, is that smaller than or equal to 1 over square root of n cubed? Cross multiply. Square root of n cubed, is that smaller or equal to square root of n cubed plus 1? I think so. But you could square both sides, couldn't you? As long as n is big, you don't have to worry about the inequality here. N cubed, is that less than or equal to n cubed plus 1? Yeah. Is 0 less than or equal to 1? Right, subtracting. Yes, it holds. That inequality should hold, shouldn't it? So we've compared it to a p-series that converges. We've shown the inequality that we need to show, so that converges. All right, one thing, please do not forget that even though you have a take-home test, that cannot be your primary focus from here until Monday. We are going to continue to move through this class. We still are going to be doing material. I still expect you to go home and do homework, all right? So for tonight, I want you to finish the homework from 8.2, which was the telescopic, and I don't know if I ever gave you the final assignment. So what I'll do is I'll email everybody the assignment for 8.2 so that everyone's clear on it, all right? Okay. Sign-in sheet get around, everyone?